Without further ado, I'm going to jump right into our technology-focused session today, driving CO2 performance. So the goal of this session is to highlight some of the latest advancements in CO2 technology performance. Our speakers today are Miguel Boscan, Application Engineering Manager with BITZER US, and Gabriele de Bona, Segment Strategy Manager for Food Retail with Danfoss. So I am going to hand things over to Miguel to kick us off.
Thank you, Morgan. Appreciate being given the opportunity to provide some information about BITZER products. And let me share my screen here. Let's see. Are we good?
Yes.
Excellent. Okay. So again, thank you very much for the opportunity, and I will go ahead and get started right away to make sure I do not take too much time here. You know, for almost 25 years, BITZER has provided technologies that support CO2 systems designers, constant pursuit of high efficiency systems. We're constantly innovating to support the market requirements and customer expectations. And today I'll spend a little bit of time to cover some of our latest products being released into the market. These include the green highlighted items on this slide here, TSL compressors with vari-step ejectors that were recently announced at Choventa, and our ME series compressors. Starting with the TE series, many of you are already aware that the official release of the TE series happened in Q2 of this year. The upgrade brings a proven BITZER Ecoline design features to our 4- and 6-cylinder CO2 model compressors. The update includes really a complete redesign of the compressor, resulting in significant benefits for OEMs and end users, with most likely the biggest benefit being the vari-step capability that I'll cover in a little bit. The compressor is completely backwards compatible with the previous TC models, but it is a completely new compressor on the inside, increasing efficiency and some other lowering gas pulsations and those kind of things that we've incorporated with the Ecoline design. A completely new product that's going to be offered and released next year in 2023 are the 4- and 6-cylinder ME series subcritical compressors. So the ME series compressors have a standstill pressure of 1450 psi on both the high and low side. This feature, in conjunction with the higher horsepower motors, allows a significant increase in condensing temperatures on the low side of the CO2 system, increasing, design options for engineers who are creating or coming up with solutions for their customers. For reference, the SL series has a standstill pressure of 435 psi and on the low side, and 770 psi on the high side. In the bottom corner here, you can see, let me change my pointer option, the increased window of the ME compressor up here versus the smaller window of the SL compressor. So the ME series provides system designers flexibility on the low side of a CO2 system. The most significant benefit include the larger displacement options. The largest ME compressor is 40% larger than the largest SL compressor. Also, for systems that require lower or higher low side standstill pressure, the ME series provides an optimized higher efficiency compressor for this application, and eliminates the need to use higher horsepower transcritical compressors. The largest ME compressor is the 6PTE, and it's about 70%, has about 70% more displacement than the equivalent TE series. So you will be able to design the low side with fewer compressors, optimized compressors for that application. And it also gives the opportunity to consider other options like eliminating the backup condensing units on the low side of a compressor, because these compressors can withstand higher standstills. The series that is the 2-cylinder series have been released for quite a while. Coming up in 2023 will be the 4 and the 6-cylinder versions. Moving on to, or I guess circling back to VariStep, with the release of the VariStep with the TE compressors, BITZER offers a low-cost, simple solution in the form of mechanical capacity regulation. This, in conjunction with the CMRC IQ module, there's the potential to operate as low as 10% of the full load capacity in the stepless mode. VFD operation is limited to 25 hertz, or about 40% of the full load capacity. So it gives you another option to control or to try to meet the part load requirements of a rack. The VariStep also allows engineers to mix and match VFD compressors with VariStep compressors to achieve the optimal balance between part load, system efficiency, and cost. So in the picture below here, we show 2 VariStep options, but you could have a VFD on the first one, a VariStep on the second one, and a standard compressor as well. So they are interchangeable and compatible with each other on a rack. The CMRC simplifies the installation and the controls. You provide the 0 to 10 signal, and the CMRC will do the rest. You know, the goal of it is to improve system efficiency on an overall basis, not compressor efficiency. The VariStep for the TE compressors, transcritical compressors, are a couple of technical notes. First, the VariStep is available only for the 4 and 6-cylinder TE models. There are 12 4 and 6-cylinder models currently. It is the same hardware and software as the CMRCs used for our HFC models. So this means that technicians and users will not need to learn new software or be able to connect with new hardware with the CO2 compressors. There are some accessory differences that connect to the CO2 compressor, like the pressure transducers and temperature sensors. They are rated for higher pressure, but the hardware module and the software are the same. One note is that the VariStep is not backwards compatible with the TC series, so you cannot take a unloader kit and a CMRC and add it to TC to achieve a mechanical unloading. BITZER also has a VariStep option for CO2 subcritical compressors, the SL series, for the smallest 2 MSL through 2 FSL compressors. The major difference between this and the TC or TE models is that the SL compressors are backwards compatible, so you could add the unloading option to a compressor that is existing in the field. And again, it's only the 2-cylinder model circled here in red, and there are 6 of those that are available. On to probably the most interesting news is the ejectors. So for those of you who attended Chillventa or were monitoring Chillventa remotely from the US, you're aware that BITZER is releasing an ejector product line into the market. So I'm not going to go into ejectors on a deep technical basis or the operating principles, because I don't know if I could do it justice here in this summit, but at a high level, the ejector basically takes advantage of thermodynamic characteristics of CO2, along with the some established physics principles like Venturi, to create pressure lift. BITZER has an excellent guide, AT744, and the principle of how it works is described much more elegantly in section 2.2. So I would go ahead and suggest anybody interested could go to that document and get some more details. Since this pressure lift is done without having to add electrical power to the system, the increased pressure lift is a direct and positive impact on system efficiency. So, which is what we're all trying to achieve, and in our system, in our going forward with our rack systems, and CO2 is has some unique characteristics that we can take advantage of to do this well. So, there are two different types of applications that ejectors typically will be found in, the low lift versus the high lift. So here are a couple simple examples of both. In the low lift example, the ejectors act as basically a refrigerant or CO2 pump. It provides, they're selected to provide the required force to move the liquid out of the flash tank through the evaporator and back. They're typically used in smaller systems without parallel compression, and so here we see, a single compressor stage as the example. In the high lift application is more typical of what you would see in the supermarket CO2 rack, and the next slide we get into a little more detail of that in the booster application. So in a booster system with ejectors, a portion of the medium temp evaporator mass flow is diverted through the ejector back to the flash gas tank after the medium temp evaporator. And that's the dark green line right here off of the suction accumulator back to the ejector. The remaining mass flow combines with the low temp mass flow and returns to the medium temp compressors. And that is seen here in the purple line, going back to the medium temp compressors. The pressure of the flash gas vessel is maintained by the parallel compressor. And this is shown in the light green line right here. The processing of this mass flow that's being diverted from the medium temp compressors to the high temp compressors is being processed at a lower pressure ratio, and therefore at a higher efficient operating point. So that's the goal of the ejector, is to divert the mass flow from the medium temp from a less advantageous pressure ratio to a more advantageous pressure ratio using the parallel compression that is already a rather common design feature of a CO2 rack. Here you can see the current product offering from BITZER. So there are 7 ejector models, all with variable geometry controlled by a stepper motor, ranging from about 6 to 7 tons up to about 82 tons for a single configuration. They can be configured in parallel for larger applications. Perhaps the biggest benefit of using the BITZER ejector is that they're going to be fully integrated into our BITZER Analog software. And this will greatly simplify the selection of the compressors and ejectors and the manipulation of compressors and ejectors to really dial into the best option for the end user, the final customer. So that release software should be in one of the next couple revisions of our software. There was a software release today that it was not included there, but it should be coming up in the very near future. Next, the last product, which I didn't mention in the agenda, is the 8-cylinder transcritical CO2 compressor. So you can see on the screen the design of the 8-cylinder compressor. It's going to be fully integrated with a CMRC. So right here you can see the unloaders on 3 of the cylinder heads. The 4th one does not have that. You have pressure and temperature transducers and sensors that connect back to the CMRC. The Delta P oil pressure sensor, oil MIQ, which oil level monitoring, all connected back to the CMRC for monitoring and functioning of the components that are attached directly to the compressor. This compressor is quite a bit larger than our current offering. So a quick comparison with our largest transcritical model, which is a 6 CTE compressor. The FTE displacement would be about 80% larger than the CTE. And the CTE displacement, the largest 8-cylinder compressor, is more than 2.5 times the displacement of our current CTE compressor. Most likely these compressors are not going to be used in your traditional supermarket, but they're a great option for any of your cold storage facility needs, really reducing the number of compressors if you would going to a CO2 option for cold storage or larger applications. This is expected to be released in late 2023 or early 2024 for BITZER US. Again, this is one option that was shown at Chilventa. If you were monitoring, there were a couple of vendor OEMs who had these on their racks in Europe. With that, I am a little right on time, I hope, with giving a few minutes for questions that may have come up, and I'll do my best to answer them.
Yeah, you are right on time, Miguel. Thanks so much for a great presentation. Just as a reminder to the folks on the line, please use the Q&A box to enter any questions, not the chat box. So first question, Miguel, is when will the BITZER ejector be available, and will it work with any control system?
So the BITZER ejectors, I can't give you a definite timeline. We have to work with a couple through some UL requirements. And we would hope to be able to do that sometime during the next year. As far as the technical requirements for the controller, that's still to be determined. Currently in Europe, the controller is a VERM controller, but those details need to be worked out for us here at the US. Okay,
great. Thank you so much. Next question is this BITZER's first ejector?
So technically, I would say, yes, it is the first ejector. We are working with a small group that has been working or developing and using ejectors for quite a few years now. I think on this slide here, they have over 7 years of experience and almost 7 million operating hours with the design. But as far as a commercially available ejector, this would be BITZER's first one.
Great. And have you seen CO2 applications for temperature applications lower than 35 degrees Celsius?
I am going to do a quick calculation here to make sure. I mean, we're in the minus 40 range. I don't have any specifics that I could tell you for sure. I know that the application window of our compressor will allow you to go to, sorry, let me go back to this other slide. We're at about minus 58. So minus 40 C is in this range, so it's well within the minus 35 C is in this range here, so it's well within our SL application window.
That's great. And if folks have specific follow-up questions that they want to dive into deeper, can they reach out to you after this session for that?
Yes, and I apologize. I should have at the last slide some contact information.
That's okay. If folks want to connect with Miguel, feel free to send me an email, and I'm happy to help connect you guys. We have another question about the ejector. Assuming the injector improves efficiency, can you describe how much by percent in the two applications you provided?
All right. I do not have a percent that I can give you over the phone that I feel, without kind of pulling it out of the air. There's a lot of information that we still need to review and consider before I could give you that. Now, like I said, in our software, we will be able to provide this information once it's integrated. In general, on the high lift side, you will be able to do some compressor selection and ejector selection to get you some efficiencies that you desire. And it all is a balance between how large and how much you want to spend on the upfront cost of the equipment versus the efficiency and the payback period. So this one is a little bit more variable in terms of the efficiency you could expect. It really comes down to what you're willing to invest to begin with. This, the low lift ejector side would probably be a little bit easier to pinpoint the efficiency gain. Again, because the ejector itself is selected only large enough to provide the proper, the sufficient force to pump the CO2 through the evaporator and back to the ejector. So with that type of selection criteria, it's easier to dial in the exact or close efficiency improvement.
That makes sense. That's always the golden question, right? And it varies so much. So it depends is a fair answer.
Yeah.
On that note, there's this constant conversation going on around the trade-off of, system simplicity versus all of these great energy saving design features on a CO2 system. Is that something, what would you say to retailers that are concerned about that trade-off, or is there anything you would like to comment on that?
Well, I mean, in general, we say these are going to become more complex and in an effort to become more efficient. But this is true over the history of supermarket refrigeration. As an effort to become more efficient, we've had to add different things over the 100 years of mechanical refrigeration. And the key, and you mentioned it in your introduction, is just being able to communicate clearly and directly with the people who are designing and supporting the equipment and training them properly so that the perceived complexity that's added is really demystified and shown in a way that these people working with the equipment can understand. It's not a good example would be cars and engines. Right? I personally cannot work on an engine anymore because it's too complicated with computers and this and that. But the mechanics who have been trained and continue to grow and follow, do some professional development are highly adept at working on these very complex systems. So I think we just have to kind of consider that transition in our industry and make sure we train our technicians and designers and users well.
Yeah, that's a great point. That's constantly coming up. Have you seen any models or practices to help make sure that the service workforce and installation workforce is familiarized with these technologies?
Well, I think in general, those who really want to understand CO2 and the complexities and simplify it for themselves really need to go out and seek different trainings from different manufacturers like BITZER and also different organizations. I know NASRC is working closely with, is it ESCO?
Yep, ESCO Group.
ESCO Group to develop training materials. There are other private training groups to provide information as well. So I think it's really incumbent upon those using this to seek out these different training opportunities so they can now get a good understanding of lots of different things, not just the perspective of one manufacturer or one trainer or one system design. Obviously OEMs, rack OEMs, I'm sure can offer a lot of insight into their specific designs, and that would also be important for to develop this expertise.
Yeah, absolutely. You're teeing up our next event, training event in California next April. So you mentioned in your presentation that Veristep can't be installed on existing transcritical series compressors in operations. Are there options available to add Veristep to existing CO2 racks with older transcritical series compressors?
Yeah, so the TC is not compatible with the Veristep. So the option would be to replace one of those compressors that you want to, maybe the lead compressor with a TE model and add Veristep to the TE model. And the compressor are backwards compatible in terms of the mounting feet and the suction and discharge connection. So it'd be an easy fit. The motor electrical data is very similar or the same. You get a little bit more displacement with the TE models, but we're talking 2 or 3%. And then you would use the CMRC to do the unloading. So it would be a matter of replacing the compressor, but it's still very possible. And it could be a good solution if you have control issues on a rack with unloading, or inability to kind of really control or meet the part load capacity you need, and also an opportunity to increase efficiency, system efficiency on a rack that already existing at a relatively low investment.
Okay, thanks. And final question I'll leave you with is, if there was one thing you could communicate to the folks on the line today, one thing you would leave them with, one key takeaway, what would that be?
Oh, I think the key takeaway is you can't run away from CO2. You've already mentioned, there are other natural refrigerants as well that pose some different challenges, but natural refrigerants are going to is the only really future-proof refrigerant, within that it's going to exist. And CO2 is a great refrigerant for many different applications when designed, the system is designed properly, but can't beat the DWP, and all the other characteristics that make it attractive going forward.
Yeah, no, that's a great point. Well, thank you so much, Miguel. We may get you back on the line here, but I'm going to give Gabriele an opportunity to share his presentation as well. So I'm pleased to introduce Gabriele de Bona, Segment Strategy Manager for Food Retail with Danfoss. If you want to go ahead and pull your slides up.
Okay, thank you, Morgan. Thank you to the audience for the possibility to be here and talk a bit about sustainability and sustainable refrigeration. Sustainability has been part of the Danfoss concept and DNA back since 2007, when we started our strategy with ambitious target for 2013, based on the 3 pillars that you can see on the slide. And of course, together with our development, we have chosen the CO2 as the refrigerant to point on and to uphold, basically because CO2 has proven to be the most sustainable among the natural refrigerant, and for the last 20 years, Danfoss has worked hard to develop a complete solution in order to make it possible to use and to have the end user and the market to take full advantage of CO2 independently on where are located and which climate condition they are in. Why to choose the CO2 as a refrigerant? Because it reduces the complexity with low and medium temperature compatibility. Is a zero ozone depletion, and of course it has the lowest global warming potential degree, because it's equal to 1, that is the minimum that you can have, and has proven to be viable solution for warmer climate too. In the past years, the development of the technology made this possible. We will see it, and also it performs good efficiency in all the climate compared to the HFC and similar other refrigerants. The CO2 is also the refrigerant of tomorrow, because despite being the first one used in the refrigeration back in the 1815, now is used worldwide, and it provide a sustainable and cost-effective solution. Also, that is proof to the environmental requirement that we have today, and for sure will be proof to the environmental requirement that we will have tomorrow. So today, CO2 is the only refrigerant that we can make sure and we can bet it will be present in 20 years from now, and will be available 20 years from now. It has a superior thermodynamic properties with a high pressure refrigerant, high density of the gas, and high volumetric cooling capacity. It has zero impact on the global warming, and with more than 30% reduction of carbon footprint on a store level for supermarket that is adopting it as a refrigerant, and can provide energy saving, a reduction of the consume of energy up to 20% also in warmer climate. Of course, it's up to, because it depends on, depends on a lot of factors of the system in design and what are the solutions that has been implemented, but these are the results that can be achieved. Danfoss has been industry leader in a CO2 solution for many years, and still is, because we can offer a complete portfolio that of product that goes into the system, starting by the electric regulation valve, motor operated valve, sensor, electronic controller for both rack and cases, electronic expansion valve, and the system manager, which can supervise and coordinate the working of all the components in order to boost the perfect performance of the system. It is important when talking about the CO2 that all the different parts of the circuit are working together, are working in coordination, because this is the only way to give and to take out the most performance and the highest COP possible from the circuit. In this regard, and in the regard of the future-proof for the CO2 application, Danfoss has been pioneering in the ejector solution. We were out with the first ejector now is almost 8 years, and by the time we have been developing a full portfolio, because the way it works and the way to make an ejector sustainable and profitable in all the installation requires that the solution have to be adapted to the different condition. Fortunately, it's not possible to have one size fit all, and for this reason, during the year we have been developing the series of ejector that can be utilized and can be working in all this possible application and climate area. The portfolio is made of 4 different ejectors. One is the high pressure lift, that is an add-on for to boost efficiency in the standard system with the parallel compression. We have then the low pressure lift model, that is most used to improve the efficiency in those applications that are lying in a warmer ambient condition. We have then a liquid ejector that allow the use and the application of our solution called CALM, that I will show in a few minutes. and a combination of the high pressure ejector and the liquid ejector for those installations that are more advanced, let me say, but also in bracket, that can grant to the installation the benefit of both the different the two ejectors. Of course, the ejector doesn't work on its own; need to be driven in a proper way, and for this reason, our rack controller, pack controller, has a built-in fully the algorithm to work with all of them, and in combination also with the case controller and the system manager, make possible to have the right capacity of the ejector according to the cooling demand of the installation. That is why we call it the multi-ejector. Is not the block that you can see here is not one single ejector, but it has up to 6 cartridges inside. And each cartridge is an ejector with different capacity, and by the activation of the different cartridges, the system is able automatically to adapt the cooling capacity and the capacity of the ejector to what is the real and actual demand of the installation. So in this way, optimizing the work of the whole system. How does it work briefly? As Miguel was saying before, I'm not going to go in deep in how the ejector works. We have literature and training on our site that can do it more efficiently than I can do. Basically, the important thing to say is that the high pressure gas that is coming from evaporator going through the nozzle. Let me change the pointer, sorry. Okay, going through the nozzle here, start to expand and get a boost in the speed. This is creating a pressure drop that is dragging the gas from the medium temperature suction line. The two gases then mix in the mixing unit and go out and go back to the liquid receiver through this diffuser. In the technology of the ejector, that is not new, because also this one is dated back in the 19th century. What is new is its application in a refrigeration system. The mechanic and the way the dimension of the diffuser, of the mixing unit, and of the nozzle are strictly related. And if this relation changes, the performance of the ejector decreases drastically. That is why we operate with different ejectors in parallel inside the same unit, and we are able to change the capacity of the ejector itself, of the block itself, without losing the performance of the component itself. Together with the ejector for in the CO2, we have also developed throughout the year different algorithm to manage and to drive the evaporation part of the circuit. Thanks to our evaporator controller, the case controller that goes on the refrigerator cabinet, we are able with our algorithm to automatically set and keep the superheat value to the maximum performance possible. In this slide, you can see this that you can take is an evaporator that has been stretched in order to have it as a single straight pipe. The refrigerant that enters the evaporator is start with a mix with a high level of liquid and some part of evaporator. It starts to evaporate throughout the pipe of the evaporator. And then at the exit of the evaporator, you will want to have fully gas, everything that is fully evaporated, not to go back to have liquid going back to the compressor. Usually with a standard controller, what the installer and contractor does is to fix a value of the superheat, so to make sure that all the bubbles have evaporated, all the fluid has evaporated. Our case controller has built in an algorithm that is capable to find out what is exactly the point and the superheat value at which all the liquid is evaporated, and to keep it and to maintain it. You can understand that also this point can change throughout the day, throughout the operation of the cabinet, because can change the condition. The cabinet has been filled with a fresh product, or is empty because the selling of the product has been very high for that day. So this value is changing. The MSS algorithm, minimum stable superheat, is able to detect this changing and automatically adapt it to the new condition. A further development to this algorithm that we have is the ALC, is adaptive liquid control, that is in combination with the liquid, working combination with the liquid ejector, can take out the most from evaporator and allow to have the evaporator use it to the most. Here is a different way to explain it. With the minimum stable superheat, you see that the evaporator is driven at the best, but of course, a last part of it, it is used to make sure that all the fluid is evaporated and is going out, only vapor. With adaptive liquid control, on the contrary, we have that the full evaporator is utilized, and you have a very small portion of bubbles that can go out of it, that are collected in a small liquid receiver that is out of just before the empty compressor, and then the liquid ejector will take care of them and we will make it recirculating into the system. This algorithm is very precise and can bring the superheat very close to zero. So allowing us also to increase in this way the evaporator temperature of the cabinet, working it in a semi-flooded condition and performing a very sustained reduction of energy increase, of energy consumption, sorry. Is a highly precise liquid control, and that makes sure also that all the small amount of liquid that may flow and may go out is captured in the suction accumulator, and then the liquid ejector will take care of it. This is the full diagram of the algorithm, control algorithm that I was mentioning before, the CAM. CAM is an acronym, but has been chosen on purpose, just to say is keep calm with CO2. CO2 is not that bad monster that you may think it is, because the technology is here to help, is a mature technology, and so it can make CO2 really usable by anybody nowadays. This CAM algorithm is working and making the work regulating the operation of all the electronic parts of the system. So the case controller, the system manager who is supervising the activity, and the pack controller, the rack controller, optimizing the evaporating effect and from the refrigerant, and allowing all the cabinet to work with a superheat value close to 0. I want to show you now some data related to the performance, relating to the performance of a CO2 system. As I was saying before, unfortunately, it's not possible that one single solution fit all the possible environmental condition and application condition. So you have here in this graph that each bar is representing a different CO2 system, standard, the booster system is a standard transcritical unit, the transcritical unit with liquid ejector, the transcritical system with parallel compression, then parallel compression, liquid parallel compression, and high pressure ejector, and the full set of parallel compression, liquid ejector, and gas ejector. As you can see here, the different cities that give a reference of which can be the climate condition, and these are the value of the comparison of the energy saving you can have, making comparison to the, let's say, old R404A refrigerant. You see that in cold, let's say, city like can be Copenhagen in Denmark, the CO2 system provide a good energy level. When you go more close toward the equator, like in Madrid, for example, or in Beijing, you have that the performance of the standard transcritical is decreasing, but still the other systems are providing good energy, good saving, and with the proper technology applied, a CO2 system can be performing very well also in very warm city, as can be Bangkok, Sao Paulo, or Riyadh, in comparison with the R404A. So this is making CO2 nowadays really usable, applicable in all the condition and in all the latitudes. An example of a case study coming from Europe. You know, in Europe, or is already almost 20 years that 15 years that the CO2 technology has been adopted and has been in use. This is, for example, a picture coming from one of the supermarket of the EDEKA. EDEKA is the largest supermarket corporation that is in Germany. And with the installation of CO2 system in the supermarket, they were able to boost efficiency, to have a consistent reduction on the carbon footprint of each single store. And also thanks to the installation application of heat recovery solution, also to provide heating to the store, heating given by the excess heating that is the refrigeration system is providing. So the installation of the CO2 with parallel compression, multi-ejector, and the CALM algorithm has increased the reliability of the system, the efficiency, and also has reduced the thermal stress on the compressor, reducing the need of servicing them. That is also can be positive from a point of view of cost reduction. I was talking about heat reclaim. One of another positive effect of the CO or using a CO2 is that you can profit by of the excess heat that the system is the refrigeration system is giving to heat up the store or heat up the tap water. We as Danfoss have developed and designed a plug and play heat recovery unit that can easily be added to the system, just a matter of connecting the different pipes, 4 pipes, And this solution can manage the buffering of the heat from the refrigeration pack and make it possible to reuse it as a space heating to make tap water, or can even be sold to neighborhood district heating grids if present in the area where is operating the store. This solution has been adopted by a Danish supermarket chain called BITZER, not a big one, but quite popular in Denmark. And thanks to the adoption of this heat recovery unit, they were able to provide the 95% of the total heat, to cover the 95% of the total heating need of the store, of each single store. And this allowed them to decrease the CO2 footprint of the store, halving them in the 5 years, and to save 70% of the cost of the heating and 77% on the electricity itself. Danfoss, the CO2 refrigeration is also part of the Smart Store. The Smart Store is a system that we have developed in order to maintain, optimize the work of the supermarket, not only on the refrigeration level, using the connectivity and the intelligence of the cloud to reduce operating cost, to reduce food waste, and reduce the service cost. The Smart Store work as an integrated system that can take care about not only the refrigeration part, but all the different systems that are present in a supermarket, if they are, like the lighting, HVAC, battery storage, car charging, electrical car charging that now are becoming more and more popular, or managing a smart grid. This system has been adopted today by 75,000 different installations that we are managing with a lot of alarm processed monthly, as you can see in the screen. To conclude this presentation, I want to spend a few words about the training possibility that Danfoss is offering about the CO2. We have a full portfolio of online learning sessions that are available for free about the CO2 refrigeration that can explain advantage, disadvantage, properties, understanding of the system, CO2 system itself, also product selection together with our software Cool Selector, that is the software that can help all the contractors and installers to select the proper components for the system. These lessons are online and are available for free on our internet site, but also we can provide hand-on training on refrigeration with the CO2, and thanks to our mobile training unit. This training unit is built inside a standard container, 20-feet container. It held a full refrigeration system, working refrigeration system that has the latest technology possible. And with this, our technicians can provide training on the commissioning of the CO2 system, on the setup of the different elements, electronic or mechanical, on the different component. They can provide training on the service procedure and troubleshooting and correction of the system operation. We are working, and I'm sure we will be able to have this unit present at the session that we are going to have, Morgan, in California next April. Our target and our aim is to have this mobile training unit in the US for that time. With this, I thank you all for the attention and for the possibility for me to make this brief presentation.
Thank you so much, Gabriele. And yes, we are looking forward to having the training unit at our event in California in April. We have time for just one or two questions. The first question is if you can talk a little bit about using CO2 refrigerant in heat pumps.
Oh, this is a good question. This is the future. It's not an idea. It's not a concept. And anybody that had the possibility to be in Chilventa last week could have seen it with his own eyes. CO2 is going to be used and is going to be the refrigerant also for the heat pumps. Maybe not for the civil application for our houses, but for commercial and industrial application is going to be the refrigerant in use for the next future. In the next future.
That we did see that theme at Chilventa. It was very strong. So that's wonderful to hear. And I will just make one quick note that if folks have more questions for either Gabriele or Miguel, another place to contact them is through the sponsor booths on the Summit platform. So Gabriele, we'll do, I think we have time for one more question. And I'm curious, you mentioned that the most common CO2 solution you're seeing today is a transcritical booster system with parallel compression. And you talked a lot about many of the other energy saving design features. Do you envision those becoming standard in the future, or do you think that it's going to continue to vary based on the needs of the supermarket and the climate? What would you say to that?
Let's say there is not going to be a standard solution because it will be depending on where it's going to be applied and the dimension of the supermarket itself. So this is also the nice of having a scalable solution that can be suitable for the small store up to the big hypermarket and in Miami as in Seattle, just to say. So I don't see a standard. So far, it has been a standard, the transcritical with parallel, because the technology was allowing us to have that. But with the progression of the technology, the introduction of the ejector and of the different control algorithm, we will see also the other solution becoming more available. It is also a matter of investment. No? So if you want to take out the most of the system, you will be in need maybe to invest a little bit more during the commissioning phase. But the advantage that the solution will take you will allow a return on investment very quick.
Okay, great. And I would love to pose the last question to you, the same question that I posed to Miguel. If you could just leave one key takeaway with the folks on the line today, what would that be?
Is that CO2 is not difficult. I mean, it can be difficult now that you see as a new technology coming to US, but it's a mature technology because in Europe has been used for the past 15 years. So we have the expertise, we have the application knowledge that can help you to go through the adoption of the technology and support you during the learning process and the commissioning process, so to make these transitions the smoother possible.
Okay, great. Thank you so much. I just want to thank again, Gabriele and Miguel. Thank you both so much for taking the time to share these insights. Thanks everybody on the line for taking the time to join us.